Now let's talk about an interesting feature called lifecycle hooks. Lifecycle hooks allow you to take action before any EC2 instance goes into service or before it is shut down. In other words, lifecycle hooks allow you to pause instances and perform custom actions when a scale-in or scale-out event occurs. Thus, when a new instance is launched or an existing instance is terminated, a lifecycle hooks can be configured to intercept it and put it in a standby state. The instance remains in standby until instructed to continue or end the standby period. During the standby period, you can perform actions, such as installing software or running scripts on the instance. By default, the instance remains in standby for 1 hour. Now, some common reasons for using lifecycle hooks include setting up an instance before it handles traffic for the auto-scaling group, or collecting important data before it terminates. So, let's take a look at what the life cycle of an EC2 instance launched by an auto-scaling group looks like. This will help us understand where lifecycle hooks come into play. Then, we have the auto-scaling group. When a scale-out occurs, that is, when an instance is launched, it always enters the pending state and then goes to the in-service state when it passes the status checks. Now, when a scale-in occurs, that is, when an instance is deleted, it enters the terminating state and then goes to the terminated state. Now, let's see how the life cycle of an instance is when a lifecycle hook is configured. Then, when a scale-out occurs, the instance enters the pending state, and this is where the instance is intersected by the lifecycle hooks. The lifecycle hook splits the instance in the pending wait state. In this state, you can perform the necessary actions, such as running a script or installing software on the instance. The instance will remain in this state until you indicate that the lifecycle hook's action has completed or the timeout period ends, which is 1 hour by default. When it indicates that the lifecycle hook's action is complete or if the timeout period ends, the instance moves to the next state, which is pending proceed. From this point on, the state of the instance is evaluated and it is set to end service, which is when it starts serving traffic to the website. Now, when a scale-in occurs, the instance enters the terminating state and is intercepted by the lifecycle hooks. The lifecycle hooks places it in the terminating wait state. In this state, you can perform the necessary actions, such as exporting logs to CloudWatch logs or taking a snapshot of a specific EBS volume of that instance, etc. The instance will remain in this state until the lifecycle hook's action is indicated to complete or the turnout period ends, which is also 1 hour by default. So, when the lifecycle hooks is indicated as completed or if the turnout period ends, the instance moves to the next state, which is terminating proceed, and then the instance is terminated. This is how the life cycle of an EC2 instance works when lifecycle hooks are configured. Now, let's look at some common cases for lifecycle hooks. Lifecycle hooks can be used to install custom software when launching the instance. This is also possible without using lifecycle hooks by simply supplying the script as user data, as we have already done throughout this course. But when combined with lifecycle hooks, we can add validation. That is, we can instruct the auto-scaling group to proceed with launching the instance only if the script has been executed successfully. Lifecycle hooks can also be used to export logs before instance termination. They can also be used to invoke a Lambda function. AWS Lambda is a service that allows scripts to be executed. They can also be used to send notifications when an instance launches or terminates. So, with all this information in mind, let's talk about this scenario we are going to set up. To use lifecycle hooks, we will need an auto-scaling group. We can use the one we have already configured above. Then, when a scale-out occurs, the instance will go to the pending state. We will configure a lifecycle hooks that intercepts instances in this state and installs a mandatory software. Normally, organizations would install monitoring or security software. But for our example, let's say Apache is a mandatory software. Therefore, we will configure the lifecycle hooks to intercept the launch and install Apache via script. The instance will only be able to complete its launch if the script has been executed successfully. Already in this in-service state, this instance is serving traffic with the Apache software installed and configured. Now, we will have another lifecycle hooks that intercepts the instances at the time of termination. Here, let's assume we have a compliance requirement to take snapshots of EBS volumes for backup purposes before the instances are terminated, or we need to collect logs from that instance and send them to CloudWatch logs. Then, when a scale-in occurs, the instance will go to the terminating state. We will set up a lifecycle hooks that will intercept instances in this phase and take snapshots of their EBS volumes for backup purposes. This can be done by invoking a Lambda function with the help of the Amazon Event Bridge service. After this, the instance will proceed to terminate. Then, we will configure the scenario in two classes. In the first class, we will configure a lifecycle hook to intercept the instance at launch time. And in the next one, we will configure another lifecycle hook to intercept the instance at termination time.